So the available is 125 milligrams per 5 milliliters. So the instructions are, we need to identify the route of administration, which we already did. So A route is by mouth, right? Because we know that's what PO means. B, the number of tablets, capsules, milliliters necessary for one dose. So if we look at one dose is 25 milligrams. And we're going to multiply it by our conversion factor. Now, remember this conversion factor, there's two ways we can write it. We can say 125 over 5 milliliters, or we can do 5 milliliters over 125 milligrams. And we're always looking at how do we cancel the unit of measure that we're trying to get rid of. And so in this situation, we're going to be actually giving the patient milliliters, not milligrams, meaning we want to know what the dose is in milliliters, because they don't have a certain number of tablets that equals a certain number of milligrams or anything like that. We're doing an oral suspension, so there's a powder. I'm assuming it gets mixed with liquid. I don't know, but so because we want to cancel out milligrams, we want to use this second conversion factor right here. So we're going to do 5 milliliters over 125 milligrams. And having those diagonal from each other will allow us to cancel the milligrams out. And so when we multiply, we're going to do 25 times 5, which is 125. So we have 125 milliliters over 125, which reduces to 1 milliliter per dose. Hold on one second. I'm having the worst allergy days. Let me blow my nose. So that's one dose. Part C says the number of tablets, capsules, milliliters per day. So we are doing 1 milliliter per day, or per dose, excuse me. This is part C. 1 liter for one dose. And then we have, and the dose is every 6 hours. So actually we can just put every 6 hours. So we're going to do 24 hours in one day, because we want our hours to cancel. And so multiplying through, how many milliliters is that going to give us? So remember, we're multiplying through, right? 24 times 1. It's going to give us 24 over 6, which will give us 4 milliliters over one day. Because our hours are canceling, right? So we have 4 milliliters per day. And then part D wants to know total number of tablets, capsules, whatever, for the whole prescription. And so since we have 4 milliliters per day, and we're supposed to do it for 10 days, the days now will cancel, and we'll do 4 times 10, giving us 40 milliliters total that we would have to dispense for them to be able to take this medication. So was your hang up this part and trying to decide which way to have that conversion factor?
Okay.
So what questions do you still have about this one?
Oh, you answered them.
Okay,
Thank you.
you're welcome. All right, so now we are going to switch gears and get into, excuse me, 5.2.5.3. So 5.2 and 5.3 is all about using ratios and proportions to solve dosage problems. So in addition to solving dosage problems by using dimensional analysis, which is where we multiply our fractions together and cancel our units, you can also use ratios and proportions. My cat just meowed and it was the funniest sound. To solve a proportion, we can use the property of proportions that states if A over B equals C over D, then A times D equals B times C, where B and D are not zero. Basically, it's cross multiplication. So if we have A over B equals C over D, we're going to take D and multiply it by A. And we're going to set that equal to B times C. And then we can solve for the missing piece. So here's what that looks like. A patient is to be given 30 milligrams of furosemide that comes in 12 milligrams per 2 milliliters. How many milliliters should be given? So when we're setting these up, you want to make sure that you're consistent with your unit of measure. So if you put milligrams on top on the left-hand side, you've got to make sure you're putting milligrams on top on the right-hand side. So the conversion we already know is 12 milligrams per 2 milliliters. So that's what we're going to start with on the left. And then on the right, we're going to put in the information that we're given about the dose. And so the patient is to be given 30 milligrams. And again, since we put milligrams on the top, we want to put milligrams on the top on the right-hand side. We don't know how many milliliters, so we're going to say X number of milliliters. And then we would be able to multiply here. So what that's going to look like is we're going to take X times 12. We're going to set that equal to 2 times 30. You don't have to worry about using your units of measure here because we can't multiply milliliters times milligrams and have it be some actual usable unit of measure. But we're being consistent in where we're setting up those units of measure in the two fractions so that we can cross multiply it and solve for that missing piece we have down here. So as we simplify, we're going to have 12x equals 2 times 30, which is going to be 60. We'll then divide both sides by 12, which will cancel these out, and x ends up 60 divided by 12 is going to give us 5. And we know that we're solving for milliliters, so our answer is going to be 5 milliliters. And it doesn't have to just be medications that we're doing this with. Like you can use any, as long as you're given a ratio of equivalent units, you can use this. So what I mean is in number 2, it says convert 3 fluid ounces to milliliters. My box of milk says 32 fluid ounces, 946 milliliters. So what this means is that 32 fluid ounces is approximately equal to 946 milliliters. So if we use our conversion factor that we know, which is 32 fluid ounces over 946 milliliters, we can set up a conversion, which says, again, we have fluid ounces on top, so we have to have fluid ounces on top on the right-hand side. And if we have milliliters on the bottom, we're going to have milliliters on the bottom over here. So plugging in the 3 fluid ounces, which is the amount that we know and we want to convert to milliliters, we can put our X down here. So cross multiplying, we're going to do X times 30. No, sorry, not 30, but 32. Misspoke. Equals 946 times 3. So 32x, and if we do 946 times 3, we're going to get 2,838 dividing by 32. And we get 88.6875. So we'll round that to approximately 88.7. And again, when we're doing these problems, we're going to get to the end and be like, what is that 88.7? What does that represent? So going back to our problem, we can see the variable was down here with milliliters. Therefore, this is 88.7 milliliters. So I'm going to let you try the next one on your own. Number 3, I'll let you see the other two that we've already solved. So at the bottom, it says a patient is given 40 milligrams of vitamin X that comes in 10 milligrams per 2 milliliters. How many milliliters should be given? So we know that this vitamin X comes in a concentration of 10 milligrams per 2 milliliters. And we want to give the patient 40 milligrams of it. But again, what this means is when we're given these conversions, it's telling us that you will ultimately be dosing the patient using milliliters because there's not a number of tablets equal to those milligrams. So we're going to solve for, I'm going to just put, well, we can use X because we're solving for vitamin X, but whatever, it doesn't matter. We just need a variable there, right? So cross multiplying, we're going to do X times 10 equals 2 times 40. So 10 times X is equal to 80. Divide both sides by 10. And we get X equals 8. And again, what unit of measure is milliliters. So we're going to give 8 milliliters of this drug to equate to the 40 milligrams that we want to dose the patient with. All right. So we can also use these in other types of problems, more dosaging problems, but so basic rules for tablet and pill medication: don't break or crush tablets unless scored or specified in the instructions. They may be coded, which is enteric, for time release or to control rate of absorption. And 1 tablet is better than 2, meaning you want to find the amount of drug that you can get with the least number of pills. So basic dosage Basic dosage calculation formula means the amount of the drug in stock H per the volume or weight Q equals the amount of drug prescribed D, or the volume or weight of the stock needed A. So these are just showing you different ways that you can set this up to solve it. Basically, we've been doing this so far, and I would just encourage you to keep that way. But these two formulas down here are showing other ways that you can solve for these variables. So number 1 says you were asked to administer 250 milligrams of Cellcore orally to a patient with a urinary tract infection. In the drug cabinet, you find a 150 milliliter bottle of Cellcore labeled 125 milligrams per 5 milliliter suspension. How much of the stock supply should you measure to give the patient? So all this information right here is telling you this 150 milliliter bottle, all that bit is telling you is how much you have available to you. You're not going to actually use that in terms of deciding actually how much to give the patient, but that would determine if you have enough in stock, basically. So to calculate this, we're going to go back to what our concentration of the drug is. So they're giving us the amount of drug in stock over the per volume or weight. So this is the amount of drug they have in stock, which is this one, over the per volume or weight, which is actually, we could do this easier. Let's just do it this way. We know that we have 125 milligrams per 5 milliliters, and we want to set that equal to 250 milligrams per X number of milliliters. Again, don't make it harder than it needs to be. We're just solving this as a cross multiplication. So we're going to do X times 125 equals 5 times 250. So we have 125x equals 5 times 250. It's going to give us 1,250. We'll divide both sides by 125. And we get X is equal to 10 milliliters. So we want to give 10 milliliters, which will obviously fit in the bottle that we have. And so we don't have to worry about not having enough stock. Okay. So then we can also calculate dosages based on body weight. Doctor prescribed ampicillin for a child who weighs 20 pounds. The label on the box recommends a dosage of 10 milligrams per kilogram per day. Calculate the correct. Damn, we don't need you in here, sorry. Calculate the correct daily amount of ampicillin that the child should receive. If the label states that there are 250 milligrams of ampicillin per 5 milliliters of liquid, how many milliliters should this child be given daily? So that's a lot of information, right? So we know that the child weighs 20 pounds. But that the dosage is given in the recommended dosage is given in 100 milligrams per kilogram per day. So in order to come up with how much we need to give the child, we first need to convert the weight to kilograms. So we know that 1 kilogram equals 2.2 pounds. So if we do our 20 pounds multiplying by 1 kilogram over 2.2 pounds, we get, what do we come up with? 20 divided by 2.2 gives us 9.09 approximately kilograms. It keeps going, it's 9.090909, but we're going to round off to 2 decimal places to be as accurate as possible. So now that we have the weight of the child, we can now use the dosage recommendation. So the dosage is going to be the child's weight and it's equal to, or excuse me, multiplying by our 100 milligrams per kilogram per day. which is going to give us 100 times 9.09 is going to give us 909 milligrams per day. So a lot of work there to where are we trying to get, right? We've come up with how many milligrams this child should receive in a day. So it says calculate the correct daily amount of ampicillin the child should receive. So if the label states that there are 250 milligrams of ampicillin per 5 milliliters of liquid, how many milliliters of liquid should a child be given daily? So we now have to use this one, which we can use with cross multiplication. So what that would look like is, and I'm running out of room here, let me move some of this work around. Okay, so now that we have a little bit more room, again, we have 909 milligrams per day. And so we're going to say 909 milligrams to X number of milliliters is equal to the dosage we have available to us, which is 250 milligrams per 5 milliliters. So if we cross multiply, we're going to do 5 times 909 equals X times 250, or 250 X. So 5 times 909 is going to give us 4545, which equals 250X. Divide both sides by 250. And we get X is approximately equal to 18.18 milliliters, which we would round to 18.2 milliliters. So we want to give this child 18.2 milliliters. So if we go back over our steps, let's review. So we were given the child's weight in pounds, right? But then the dosaging was given in kilograms, number of milligrams per kilogram. So again, first step, step 1, was to convert the child's weight to kilograms, which we came up with the 909 kilograms. After that, we had to come up with the recommended number of milligrams based on the child's weight. So that's where we came over here to the dosage recommendation. And we took the child's weight and multiplied it by how many milligrams per kilogram per day, which means they need to have 909 milligrams per day. And then after that, we finally used the available drug of 250 milligrams of ampicillin per 5 milliliters in order to solve for how many milliliters the child should be given. So that's where we set up our cross multiplication, or our proportion, and we were cross multiply and solve for the number of milliliters. So we've got a couple of these problems. They're going to be more and more involved. And so we got to break them down into the pieces, right? And so I want you to think about what needs, like, what step, think about breaking it down into smaller. So look at the weight, then look at what they need to be given, and then finally look at converting it to what's available. So the next one says the recommended dose for cefaclor is 20 to 40 milligrams per kilogram per day. So this 20 to 40 means that we have a minimum and a maximum, and the dose has to be somewhere within there inclusively. So it can be 20 and it could be 40, but it has to lie within there. Okay. The strength is 187 milligrams per milliliter. If a patient weighs 18.2 kilograms, find the range of dosage. And so the range of dosage, and this is going to be in milliliters, And the reason why I know it needs to be in milliliters is because they're giving me the strength in milligrams per milliliter, which means we're going to end up converting those milligrams to milliliters. So we have a min dose, and then we have a max dose. And the min dose is going to use the 20 milligrams per kilogram, and the max dose is going to use the 40. So with these, we always start with the patient's weight, meaning we know that the patient weighs 18.2 kilograms. And we're then going to use the dosaging, which says for the minimum, we've got 20 milligrams per kilogram per day. And then the max, we would do the 18.2 kilograms. But instead, we're now going to multiply it by 40. So we've got 40 milligrams per kilogram per day. So before we get into the strength, we want to simplify this to know what the minimum number of milligrams is per day and what the maximum number of milligrams per day is. So we're going to multiply through. Our kilograms will cancel. And so we're going to have 18.2 times 20, which gives us 364 milligrams per day. And on the max side, we're going to, again, our kilograms will cancel, and we're going to do 18.2 times 40, which is going to give us 728 milligrams per day. So now we know that the strength available is 187 milligrams per milliliters. So we need to know what the minimum dosage is in milliliters. So we're now going to use that new amount that we found, the number of milligrams. And we're going to multiply it by our conversion factor. Now remember, this conversion factor, there's two ways we can put it, right? We can say 187 milligrams for 5 milliliters, or we can say 5 milliliters for 187 milligrams. So plugging this in, because we want our milligrams to cancel, we're going to want this second conversion factor set up. So we'll do 5 milliliters for 187 milligrams. Multiplying through, we're going to have 364 times 5, which gives us 1,820 divided by 187, which gives us 9.7 milliliters approximately. Because again, our milligrams are going to be canceling, so we're going to get an answer in milliliters. For the second one, we're going to take our not 364, I'm sorry. We're now dealing with the 728. And again, we're going to multiply the same conversion factor. And that is going to give us what? I'll let you finish calculating that. I'll be right back. All right. Something in my throat today. So again, if we multiply, we're going to have 728 times 5, which gives us 3,640. Over 187, which reduces to approximately 19.5 milliliters. So Our range of dosage, the minimum dose is going to be 9.7 milliliters per day. And the max dose is going to be 19.5 milliliters per day. So we may be given a problem where we're given what the doctor has ordered and then also given the recommendation, and we have to determine, is that order within the range of the recommendation or not? This is not one of those problems. We're just figuring out what that range is, but we may be taking it a step further and looking at that. So again, our dosaging needs to be, so the order, like if the doctor ordered a prescription, it would have to be between 9.7 milliliters per day and 19.5 milliliters per day. So we have one more problem that we're going to look at, which has to do with calculating body surface area. So kind of like, it's interesting, 5.2 and 5.3 is kind of a hodgepodge. It's all these different medical things that we're doing. They kind of fit together in these two sections. I don't know why they do it this way, but they do. So body surface area, it depends on which formula you use based on how they're giving you the patient's weight. So if they give you the weight in kilograms, you would be using the formula on the left. If they give you the weight in pounds, you would be using the formula on the right. BSA is measured in meters squared in both the metric and the US calculation. So your answer would be in meters squared. So number one says calculate the BSA for a person that is 5 feet 10 inches tall and weighs 200 pounds. So if you look at our formula, because they give us the weight in pounds, we're going to use the US calculation. So height must be in inches. So step one would be to convert height to inches. Meaning I have 5 feet 10 inches. So remember 5 feet is, there's 12 inches in a foot. So that, if we do 5 times 12, will give us 60 inches plus, so we have 60 inches plus those additional 10 inches, which gives us a total height of 70 inches. And then we need to know their weight in pounds, which we're given. So step two is going to be to plug our values in and calculate BSA. So this, I want you to be aware, this square root symbol is over the entire fraction. So we're going to plug in this stuff. We have the weight in pounds, which is 200, times the height in inches, 70, divided by 3,131. So let me pull up my calculator that's on my computer so that we can talk about the way that we want to enter this. Okay, so let's figure out what's in there. So we have 200 times 70 in the numerator. So that's going to be what we need to do first for our order of operation. So we get 1,000, or excuse me, 14,000. So we can say we've got the square root of 14,000 over 3,131. Now, we want, if we were to divide this by 3,131, we're going to get this big decimal, right? And we need to take the square root of that. If we round this and then take the square root, our answer is going to be off. So instead, what we need to do is we need to take the square root, but within the parentheses, see how we got a parenthesis here? We're going to do 14,000 divided by 3,131, and then we'll end our square or parenthesis. If you do not have this type of calculator, I think the other calculator options, you could I think at this point up here where it says 4.4714, I think if you just press the square root button on your calculator, like if you have a less number of function calculator, I think it'll work that way. But if you have the graphing calculator, this is the way that you're going to want to enter it so that you get the actual square root of that division. So when we enter this, we end up with a BSA of 2.1145, blah, blah, blah. So we're going to round that to 2.11 meters squared, because again, the body surface area is always calculated in meters squared. And I think there's something to do with dosaging or something to do with body surface area. I don't know. They just ask us to teach it to you, how to calculate body surface area. But I'm not really sure what the actual usage of it is. I think there's something to do with dosaging though. But again, I'm not a medical professional. I can just teach you the math behind it. So that's everything for 5.2 and 5.3. If we look at our schedule, we've got, let's see, the notes for today are going to be due tomorrow. But today, what we have to do is the pharmacy calculation homework. And then don't forget, test 2 is due Thursday. So if you have not started that or you've not started the review, I would get going on that. And then on Thursday, I'm going to teach 5.4, 5.5, and 5.6. So that is going to be what's coming next. So any questions for me before I let you go? All right, well, if there aren't any questions, I'm going to let you go. I hope you all have a great day, and I will see you on Thursday.
Okay, bye. Thank you.
Bye.